Thank you everyone for joining this Vulkanised webinar to explore the latest updates to Vulkan 1.3 and an overview of the Android baseline profile. First, a couple of housekeeping items. If you have any questions during the presentation, please ask them using the Q&A feature located on your Zoom toolbar at the bottom of your screen. We're recording this webinar and we'll share the link when it is available. At the end of the session, please complete the short survey form to help us better design future Vulkan events. To start off today's webinar, we have the Vulkan Working Group Chair, Tom Olson, who will speak about reducing fragmentation in the Vulkan ecosystem. Tom?
Okay, let me share my screen. Well, I would ask, can you see my screen? But how would we know?
It looks great.
Hello everyone. Welcome to the latest installment of Vulkanised. As Jeff said, I'm Tom Olson. I work for ARM and I chair the Vulkan Working Group. As advertised, this edition of Vulkanised is devoted to the latest updates to the API and ecosystem. But in particular, it's devoted to the three announcements that we made last week. First, we have a new core specification, Vulkan 1.3, which provides a new baseline for the Vulkan API across all markets. It defines features which we expect to ship on every Vulkan device going forward and to be backported to every Vulkan device that is capable of receiving driver updates. Perhaps not right away, but soon. Second, there's a specification we call Vulkan Roadmap 2022, which defines capabilities beyond what's in core Vulkan 1.3. We expect these capabilities to become baseline functionality in a subset of the Vulkan device market, which we call immersive graphics. I'll explain what that means later in my talk. Third, there's a system of profiles, which give us tools, both intellectual and actual software, for talking about and managing differences in device capabilities, aka fragmentation. We'll have 4 speakers followed by a panel discussion. I'll start off with the big picture, talk about what we're trying to accomplish with this release and how the 3 components are supposed to work together. Ralph Potter from Samsung will explain Vulkan 1.3 from a technical perspective. Tobias Hector of AMD will talk about Roadmap 2022, and Trevor Black of Google will talk about the Android baseline profile. We'll run the talks back to back without breaks, so if questions come up during the presentations, drop them into the Zoom Q&A, not the chat, and we'll address them in the panel session. The panel will be led by Piers Daniell of NVIDIA. Panelists will include the speakers, plus several other distinguished and active members of the working group. Should be fun. So, what are we trying to accomplish with this release? Well, spoiler alert, it's in my title. The theme of this release is reducing, or at least managing, fragmentation. I'll start with a quick look at where Vulkan is today, and then I'll take you back in time, talk about how we got here, how Vulkan's goals and evolution made fragmentation in some sense inevitable. I'll explain how we thought about the problem, how it drove the design of Vulkan 1.3, the profile system, and the roadmap. Finally, I'll talk about the status of the various components of the release and hand off to the other speakers. Vulkan today is everywhere. It's supported by all the serious GPU vendors except Apple. It's available on a very wide range of platforms: Windows, Linux, Android, 2 streaming platforms, SteamOS, Switch. And if you're willing to squint a bit, it even runs on Apple devices, despite the fact that there are no Vulkan drivers. That's done using a high-performance shim layer that you ship with your application. And at a higher level, pretty much any serious game engine today has a Vulkan rendering path. Even on Android, where only very forward-looking handset vendors offer driver updates, it's now the case that Vulkan is supported on 71% of active devices. That's according to the dashboard at developer.android.com. I'm very grateful that Google publishes these numbers and keeps them up to date. Of course, the point of all this work is to deliver content. And as Vulkan has become more widely available, applications are following. On the games front, Khronos's DevRel team counts over 370 titles across mobile and desktop, including very high profile and commercially successful games like Roblox and Fortnite. There are also very interesting non-game applications such as Adobe Rush and Autodesk Fusion 360. So that's where Vulkan is today. And of course, we're delighted, but we're also very aware that we can't rest on our laurels. A lot of people are betting large sums of money, not to mention their careers, on Vulkan's success. And we feel a tremendous responsibility to deliver for them, to keep the API and the ecosystem constantly moving forward. So how did we get here? Vulkan is just about to turn 6 years old, but it was actually 10 years ago in 2012 that we in the OpenGL and GLES committees convinced ourselves that although there were many good things about OpenGL, it was reaching the end of its useful life, at least as an API for high-performance gaming. It had fundamental problems that just could not be fixed in a backward compatible way. So we started sketching a next-generation API. It began as a skunkworks project and went into high gear in 2014 when Valve, Epic, and several other high-profile game developers joined the group. AMD donated Mantle to Khronos, and after a lot of work, it became Vulkan 1.0. Since then, we've been releasing new versions every other year, up to this year with Vulkan 1.3. A bit of a digression, I want to stress that API evolution is only part of the story. With each new version, we've taken on more responsibility for evolving the ecosystem as well. When we released 1.0, we made a strong commitment to being more open and developer-facing than we had been previously. So we open sourced the specification, the conformance test, all the tools, and created an advisory panel of senior developers. After the release of 1.0, we found that although we'd provided the best conformance test we could, early implementations were quite buggy. So we began investing heavily in conformance test development, to the tune currently of close to $500,000 a year. Later, at the urging of LunarG, we took responsibility for making sure new functionality, including all extensions, at least all vendor and EXT extensions, KHR, has validation layer support. We started a DevRel program, which led to improvements in our documentation and the creation of the Vulkan samples repository. And now with Vulkan 1.3, we're changing how we construct core versions and introducing a roadmap and profile system. But although this is something different, it is not at all a change in philosophy. We've always felt that if there are problems that get in the way of people using Vulkan successfully, it doesn't matter where they are, in the API, the implementations, platforms, tools, or the ecosystem as a whole. They're never not our problem, and it's always our job to address them as best we can. So going back to history and where Vulkan fragmentation comes from. In 2014 and 15, when we were designing 1.0, we had, of course, many technical goals. The API should be lightweight, support multi-threading, and so on. But we also had ecosystem goals. Like OpenGL, the new API had to be cross-platform. The ISVs in the working group told us it had to support 4 to 5-year-old desktop hardware, so at least as far back as GCN and Fermi. And we already had a goal of supporting both desktop and mobile. So the API had to handle, depending on how you count, a range of 1 to almost 3 orders of magnitude in capability. And by the way, we had to get the design done in a year because the need was urgent. So how do you do this? What we did, after we designed the architecture, which was actually the hard part, was to take OpenGL ES 3.1 as the hardware min spec. That was actually suggested by Johan Anderson. Then we looked at the list of hardware features we wanted to expose, prioritized it, and specified as many of them as we could in the time available. We made the ones ES 3.1 hardware could support mandatory, and we made the rest optional, adding feature and property bits. The reason we put the optional features into core was that we wanted to signal that they were official, fully supported, fully conformance tested, that IHVs should support them if they could, and developers should feel comfortable using them. And that was 1.0. After 1.0, we began writing extensions and eventually switched to a policy of doing all our technology development as extensions. A lot of the early extensions were frankly bug fixes, fixing things we got wrong in the spec or just hadn't had time to specify in 1.0. Some were API improvements, making the API extensible and easier to use. And there were a few hardware features from our backlog. So when it came time to define 1.1, we rolled in all of the bug fixes and API improvements and made them mandatory. And we included a few hardware features, which again were optional because there was hardware out there that couldn't support them. The result was basically what Vulkan 1.0 should have been if we'd been able to see the future. After 1.1, we did a few more bug fixes and also made a number of more far-reaching, what we call quality of life improvements. These are things that don't add hardware functionality, but which make the API better, more usable, give developers better information about the implementation, or make developing applications easier. These include imageless frame buffer, timeline semaphores. We also added some more advanced hardware features, actually quite a few, like descriptor indexing. When it came time to define 1.2, we had to decide whether to raise the hardware min spec beyond ES 3.1. But Vulkan adoption in Android was going slower than we wanted, and raising the bar would have made it worse. Also, people were starting to use Vulkan on more deeply embedded platforms, wearables, automotive, and such. Those platforms have simpler needs and are very cost sensitive. Raising the bar would have added cost for them without adding value. Last but not least, raising the bar would have meant that older devices would be stuck on Vulkan 1.1 and would not get the benefit of the quality of life improvements that 1.2 provided. In the end, we kept the hardware bar at ES 3.1. We added 24 extensions to 1.2 core, but a large fraction of them, including all of the most exciting ones, were optional. After the release of 1.2, we looked at where we were and decided that the path we were on was not sustainable. The core API was accumulating more and more optional features. Developers didn't like that. We didn't like it either. Promoting extensions to optional core features had some value in terms of signaling a direction, but not enough to justify the disruption they caused. Jesse Hall from Google articulated it in a phrase which became sort of a mantra for us. Turning optional extensions into optional core features doesn't give developers anything of value. In fact, it makes the API worse. And of course, beyond that, we were adding optional extensions outside the API as well, in the form of KHR and EXT extensions. We're currently at 180. Many of those extensions were quite important, especially for desktop implementations, and developers very much wanted to use them. The result was what developers call capsbit hell. They were stuck with no easy way to know what combinations of features they could safely target. Similarly, GPU vendors had no guidance as to what features to prioritize in upcoming products, so they were making guesses. Of course, they were consulting developers and developer input helped, but in general, they made different decisions and ended up supporting different sets of features. This was bad for everyone. So what to do? One observation we made in thinking about the problem is that any API that spans many markets and 2 to 3 orders of magnitude in performance is going to be fragmented. It's unavoidable. The hardware cannot be the same across that range of products. So we cannot completely avoid fragmentation. The best we can do is minimize it and give people tools to manage it. Fortunately, although Vulkan as a whole is fragmented, within market segments, it's much more coherent. All mobile hardware supports ASTC and ETC2. All desktop hardware supports BC 1 through 7, etc. The solution is obvious in hindsight. We needed a profile system. We had actually tried to design one earlier. We sketched something we called feature sets because feature levels was already taken. But those discussions always broke down, in my view, because we were thinking of it as a marketing and branding exercise. like Vulkan Ultimate. But when we started thinking about it as a tool to help developers manage fragmentation, suddenly all things became possible, and we were able to come to consensus. Of course, we were having these discussions in the context of deciding on goals for Vulkan 1.3. Profiles gave us a way to raise the hardware min spec in a market-specific way, so there was less pressure to raise it in core. Leaving the min spec low means that even deeply embedded devices can run the latest version of Vulkan. Where we ended up is that for 1.3, and going forward at least for a while, we'll keep the hardware min spec at ES 3.1. New core versions will get only features that can be implemented everywhere, but that will include API and quality of life improvements, and all of them will be mandatory. When there's an opportunity to raise the hardware bar in specific markets, we'll do it using profiles. This idea is now so embedded in our thinking that I think we've convinced ourselves it was always obvious to us. But in fact, all ideas come from somewhere, and I actually found this one in the minutes from a meeting in September 2020. Shannon Woods of Google said, considering the various options for 1.3, my favorite option, put programming model stuff into core, make that required. Things like new versions of SpearV, Synchronization 2, Timeline Semaphore. Use profiles for things that are universally supported in parts of the ecosystem, but not other parts. And that is exactly what we ended up doing. So what's a Vulkan profile? It is a formal specification of minimum capabilities across a set of conformant Vulkan implementations. Specifically, a profile defines a required minimum core version, a list of required features, properties, and formats, and a list of extensions. And that's all it is. It's as if you took the core spec required by the profile and edited the features and limits chapter and the format requirements table to impose tighter requirements. Profiles exist outside the spec. They don't have to be mentioned in it, although they can be. The spec does not define APIs for interacting with profiles, so Vulkan drivers don't have to know what profiles they support, although again, they can. Whether a profile is supported depends only on the API version number and the features, limits, and formats exposed by the implementation. This means that you can write new profiles that describe the functionality of old devices, which is very useful, as you'll hear when Trevor talks about the Android baseline profile later in the session. Once you have profiles, they turn out to be useful for all kinds of things. Basically, anything that requires precise communication of device capabilities. You can specify platform recommendations or requirements. Valve could say, for the best experience on Proton, use a GPU that supports the Proton 2023 profile. If there was one, there isn't, but Valve could define one. Similarly, you could define application or game engine requirements. You could use profiles to define market segments. If we wrote the appropriate extensions, somebody could define a Vulkan Ultimate profile that would match the features of DX12 Ultimate. And if you don't look too far ahead in time, you can use profiles to specify a future hardware roadmap. Speaking of which, profiles are great, and they will definitely help people understand what features are available in specific market segments. But they're not enough, because they don't do anything about fragmentation within a market segment. We need a way to get agreement on a baseline feature set for a given segment. In other words, a roadmap. We came relatively late to this realization. I want to credit Tobias Hector, who will be speaking later, for introducing the idea and then relentlessly beating the drum until we realized that he was right and got on board. Now, getting consensus on a hardware roadmap is a very hard problem because hardware design pipelines are multi-year, and it's very hard to get GPU vendors to even discuss, let alone agree on, what features they're going to put in future GPUs. We don't expect to be able to do it perfectly, but we can agree on some things. And by doing that and communicating the results, over time, we think we can reduce fragmentation within markets and help developers targeting those markets plan for and even influence the features that will be available in future devices. There are three key design decisions: what devices the roadmap is for, what's the time frame, that is, how far ahead are we looking, and what features do we require. So now we come to the Vulkan roadmap. For what market segment, we decided to keep it simple initially and just have one roadmap that targets what we call immersive graphics, which is defined as mid to high-end smartphones, tablets, laptops, consoles, and desktops. Obviously, you can slice the device space up much more finely than that, but we're not sure it's useful, and we didn't want to artificially segment the market. For what time frame, we defined our first milestone to be quite near term. The criterion for putting a feature into Roadmap 2022, which is the first milestone, was that all Cronus members building devices for the target markets will offer some devices that support the milestone features by late 2022-ish, maybe 23. As to what features are required, well, I hate to tell you, but the hardware feature set for 2023 GPUs is already frozen at every GPU vendor I know of. So that made it easy. We just took a poll. What are you going to support? That's all I will say about the roadmap. Tobias Hector's talk coming up will cover it in much more detail. Roadmap 22 is just the first step in our roadmap journey, but our plans at this point are loose. Future milestones will likely be further out in time, far enough, we hope, to have some influence on hardware. They will necessarily be more qualitative, talking in terms of problems to solve, rather than specific detailed features and extensions. As the target date approaches and our solutions become better defined, we'll issue profiles to specify them more precisely. Turning now to release status, Vulkan 1.3 was released last week. Conformance, I'm trying to confirm, but I believe it will be public on Friday. Some language components, Spearby tools, etc., are already public. Others are close behind. SDK support is planned for mid-month. Ghavam from LunarG is directing the project and will say more about it in a minute. And finally, I'm delighted to say that we have conformant 1.3 drivers from 4 vendors, and some, possibly all of them, support the Roadmap 2022 profile. Later speakers will say more about profiles in the roadmap, but I did want to say that the profiles repository exists, it's public on GitHub, and as you'll hear from Karen, beta tools to work with profiles are coming in the 1.3 SDK. There's a profile that describes the Roadmap 2022 milestone. It's in the repository, and it's also defined in text form in the 1.3 specification. Now I'll hand over to Karen for a few slides to talk about what's coming in the SDK. Karen?
Thank you, Tom. So yeah, some highlights on the upcoming SDK that will be coming out in February. So firstly, about the Vulkan profiles. The Vulkan profiles tool set that we will be releasing has 3 main components. The API library is included in the Vulkan application and can check for profile support and create a VK device instance with profile features and extensions enabled. It requires Vulkan 1.0 plus the VK-KHR Get Physical Device Properties 2 drivers. And then there's the Vulkan profiles layer, and it's a layer that's used during application development to simulate a profile on a higher capable device. It's used in conjunction with the validation layer, so you can use that to ensure your application is adhering to the capabilities and limits of the profile. And the third main piece is the Vulkan profiles JSON schema, which is defined in the data format of Vulkan profiles files and enables validating profile files that are correctly defined. And you can do this validation with many JSON schema validation tools already available today. Included in the 1.3 SDK will be 3 profiles. The Roadmap 22 profile, which Tom has been discussing, is the working group agreed definition for a new functionality baseline. The Android Baseline 2021 profile is a collection of functionality that is broadly supported on Android today. And the LunarG Desktop Portability 2021 profile is for common desktop platforms supporting Vulkan 1.1 on Windows, Linux, and Mac. And these profiles will also be documented in a human readable format that is generated from the JSON profile files. So this will allow for easy comparison between the 3 profiles that are included in the SDK. I do want to note this profiles layer is going to replace the DevSim layer. The new profiles layer will be able to support all of the existing DevSim functionality through the profiles config file mechanism. And we are calling this first release of the Vulkan Profiles toolset as beta quality. It will stabilize quickly once we've had broader usage of the toolset, but it has been a very aggressive schedule and we were not comfortable saying it wasn't beta when it first comes out. Next slide, Tom. Tom, next slide.
Yeah, I'm stuck. Bless Zoom's little heart. There we go. Huh.
There we go, thank you. And one other thing, so we all know that the performance of the validation layers is an issue for many application developers. We're very much aware of it. We have been focusing resource for a year now working on improving it. We do have a significant performance improvement coming in this SDK, and that is what we're calling fine-grained locking. So the validation layers have had global locks for every call, and those have been removed. And that was a significant cause of performance issues since most applications are multi-threaded. We tested this as best we could with many, many game titles, and we were seeing that performance improved in many titles by about 150%. So this is a significant performance improvement. For the first release, we will have it off by default. You can easily enable it with the Vulkan configurator. Probably by the next SDK, and once it's proven to be stable, we will turn it on by default. And I would like to mention that there is a deep dive tutorial coming on this in about another month, where we will give more description about how to use it and what to look for. And I didn't mention previously, we will also be doing a deep dive tutorial on the profiles toolset, also showing you in detail how to use the toolset. And that's all.
Thanks, Karen. I'm almost done too. We have lots of resources available to help you get more information about this release. You'll find links either at vulkan.org or on this slide. Note that we're planning to do another webinar, as Karen said, later in the month. I think it is still supposed to be in February, after the release of the SDK. This will be much more technical, deep dive, and we'll talk extensively about how to work with the beta profiles tools. Next up, please welcome Ralph Potter from Samsung, who will talk about the technical content of Vulkan 1.3.
Okay, thank you, Tom. So in this portion of the presentation, I'm going to cover the technical functionality that we added to 1.3 core. So let's get started with that. So Tom's touched on some of this already, but with previous Vulkan releases, we've promoted functionality that we regarded as significant, pervasive, and mature into the core API. But not all functionality is suitable for all devices. Hardware features cost area on the GPU. That area could otherwise be more shader cores or could be cut for a more cost-effective GPU. So we wanted functionality that we regard as important to be in the core API, but we also wanted Vulkan to remain implementable on OpenGL 3.1 class hardware, things like lower cost phones, wearables, infotainment systems, that sort of thing. In the past, we've resolved this issue by including optional features in the core API. This has served us fairly well, but Vulkan is now 6 years old, and we think it's starting to show some issues with scalability. The number of optional features in core would only continue to grow and become harder and harder to manage. Tobias Hector from A&D will talk later about how we aim to manage that with the roadmap, but the key takeaway for this part of the presentation is that almost everything that we added it to core for Vulkan 1.3 will be mandatory. We want you to be able to rely on your new core functionality being available. There's one case where we maybe haven't quite achieved that, but I'll call it out later. So as shown on the previous slide, for Vulkan 1.3, we've promoted 23 extensions into core. For the webinar, I'm not going to dwell on this slide too long, but if you're watching the recording back later, then here's the full list if you want to hit pause and scan through it. For the rest of this presentation, I'm going to go through and call out some particular highlights. Arguably the biggest one, dynamic rendering. So render passes, and particularly the single pass case, has been a recurring area of developer feedback. Desktop applications typically don't make a lot of use of multiple subpasses. And on mobile, while the gains from subpasses can be significant, they aren't necessary for every application. Render pass, VK render pass and VK frame buffer objects have historically been somewhat awkward to use. They introduce a coupling that requires information that's not always easily available at all points in the application's lifecycle. So dynamic rendering replaces that with a minimal set of requirements, making it significantly easier to use. Essentially, we've pulled the minimal set of data that current drivers do need out into a new set of structures and allowed developers to supply that instead of VK render pass objects. For the single pass case that this is focused on, this is equivalent performance to the existing API, even on mobile. We do have a future extension coming to address usability for the multi-sub pass or tile-based deferred case that's more prevalent on mobile. Support for dynamic rendering is available now on desktop. As with the rest of Vulkan 1.3, on mobile, this will take a while to become pervasive. So if your target device in your market supports dynamic rendering, then it's a much more convenient API to work with. Pragmatically, if some devices that you're targeting don't support it, then the existing API will continue to give equivalent performance, and it may make sense to wait until the multi-subpass case is covered rather than maintain two rendering paths. So pipeline compilation is another area we've received a lot of feedback over the years. These two extensions will give you more control over how the pipeline cache behaves and more feedback over where time is being spent in the pipeline cache. So cache control allows you to fail pipeline creation immediately on a cache miss, skipping compilation, to early exit batched pipeline compiles rather than compile the remaining pipelines, and to skip the internal locking on pipeline caches and fall back to external synchronization in your engine. All three of these can help reduce unexpected stalls if you have a streaming asset system and you're trying to create pipelines on the fly. The creation feedback extension provides you feedback on the pipeline creation process, unsurprisingly. Specifically, it will tell you whether the pipeline cache was hit or not, whether providing a base pipeline and using pipeline derivatives resulted in a performance gain or not, and both per stage and whole pipeline creation timing information. Another piece of developer feedback that we're responding to, dynamic state. So static state compiled into your pipelines requires more pipeline objects, requires more compiles, may introduce hitching if you try and do it on demand in the middle of a frame. Making states dynamic reduces that. So we've promoted the extended dynamic state and extended dynamic state 2 extensions. As developer advice, you should assume that setting dynamic state is broadly equivalent to the driver writing a value to a register or patching a value in memory. And you shouldn't expect it to be equivalent to triggering complete recompilation of your pipeline behind the scenes, as might have happened in some OpenGL drivers. There are a couple of dynamic states that exist in the extensions that we didn't promote to core, patch control points and logic ops. And the reason for that is essentially what I've just described. There are some devices out there that cannot do this at the performance level I've just described and would have had to do some kind of recompile. And so instead, what we've done is we've opted to give you what we could make universally available on all hardware. We've also added support for a number of new image formats to 1.3 core. Texture compression ATC HDR is high dynamic range profile ASTC. The 4444 formats adds a couple of packed 16-bit formats that exist in other APIs but didn't exist in Vulkan, primarily used for API translation, but you may find other use cases there. And we've added 4 new YCB CR formats, primarily for video encode and decode. These were not included in the sampler YCB CR conversion extension, so we're adding them now. The one caveat I would add for this is hardware support for the formats themselves is optional in core, but what we have done is guaranteed that all implementations will recognize the enums. They will understand what you're asking for when you query for those formats in the same manner as all the other formats. In terms of shader extensions, we've added the shader integer dot product extension, which does sort of what you would imagine from the name. It gives you dot products on integer vectors. It's useful for machine learning applications, but also available for general usage. We've added non-semantic info, which is SPIR-V instructions that are guaranteed to be ignored by the driver, but may be useful for tools such as debuggers. So for example, the debug printf support in the validation layers relies on this functionality. And then finally, 2 more. There are some subtle differences in HLSL and GLSL with how discard instructions work. And SPIR-V's opkill didn't fully capture this, so we've added extensions to more precisely specify that. With 23 extensions added, there is a bunch more stuff that I just don't have time to cover today. A couple of callouts that are possibly worth you going and having a look. Synchronization 2 is usability improvements to synchronization that should make your life easier. Subgroup size control for greater control over subgroup behavior is also worth a look. Some of the others here are infrastructure to allow us to extend the API in future. But overall, we've got a long list of extensions. There's a good chance there's something that's of value to you. Finally, there are a few changes beyond extension promotion that I just want to mention before I wrap up. One is support for SPIR-V 1.6. We've also taken a few features from 1.2 and made them mandatory. So that's buffer device address and some of the Vulkan memory model features. These effectively transform some optional promotions in 1.2 into universal mandatory requirements in 1.3. So again, carrying on our promise that things will be universally available. And finally, in order to bring the inline uniform block extension to core, we had to add a new limit that wasn't in the original extension. This is simply a matter of there's a piece of hardware that otherwise couldn't implement the extension. And if we're going to make something universally available, we have to provide a way to accommodate that. So that brings me to the end of my presentation. We didn't have time to cover absolutely everything that we added to 1.3 core, so I'll just point you to the same resources that Tom shared earlier for more information. Next up, please welcome Tobias Hector from AMD, who will talk about the new Vulkan roadmap and its 2022 milestone. Thank you.
Thanks, Ralph. Hopefully everyone can see my screen. So yeah, I'm here to talk about the roadmap 2022 milestone, which we're sort of positioning as a new baseline for immersive graphics. What do I mean by that? Well, assuming I can actually get clicked. There we go. So as Tom talked about earlier, we have the roadmap, which is aiming to reduce fragmentation along with Vulkan 1.3 and the profile system. The roadmap in particular is aimed at a particular target market, and it's aimed at immersive graphics experiences, things where graphics are kind of a key feature of what you're trying to do, things like high-end gaming, content authoring, visualizations, or interactive media. The first step on that roadmap for us is the 2022 milestone. Unlike most of the milestones we intend to do in future, the roadmap 2022 milestone was done on a relatively short time frame. So as Tom said, there's not really been time to change the hardware roadmaps and align with that, but we did still get a bunch of interesting features in. So the first of those I want to talk to you about today is one that developers have often requested to be made standard, because not being able to rely on it is kind of difficult, because it does change quite drastically how you approach resources within your own engine. If you don't have descriptor indexing, the way you upload resources to a shader is through a descriptor set, and you will have a low number of max descriptors or resources for each set. You can have arrays in them, but they can only be indexed statically, either via constants or known uniform values. Descriptors have to be uploaded to sets before you even record them. And if you need new descriptors to be streamed into your engine, then you need to find a new descriptor set or one that's no longer in use. With descriptor indexing, we've flipped things a bit, and it now looks a bit more like managing memory. For a descriptor set, you now get a high number of maximum number of descriptors per set, at least 500,000 for most resources. You're allowed to index dynamically by whatever mechanism you see fit, which enables things like GPU-driven rendering and allows applications to have multiple passes coordinating around which resource is being used. It also enables you to stream descriptors in and out of the same set while the set is in use. It doesn't matter if it's already been recorded. You can, as long as the GPU isn't actually accessing a descriptor, you can go ahead and just put a new descriptor in that slot. So there's no need to create new sets. You just allocate a handful of large sets at creation time, use them everywhere, and update them as you need to. This simplifies how resource management is performed, both in the API and from the side of the shaders. The next thing, which we've kind of added / required more of, is subgroups. The idea being that hardware typically runs threads in parallel, particularly on GPUs, but groups of threads will execute locally to the same processing unit. Subgroup operations that we've added expose the ability to coordinate these threads and communicate between them. This functionality has actually been available since Vulkan 1.1, but it has been highly optional. The required subgroup size has been 1, and there's not actually that much utility in being able to communicate with yourself. From the Roadmap 2022 baseline, we actually now require that there must be at least 4 invocations available. So any GPUs supporting Roadmap 2022 will have a subgroup size of 4 or higher. We also require operations to be supported in fragment and compute shaders, where before it was just compute, and a large selection of operations must now be available. It's not all of them. There are a couple outside of what I've put here that are interesting, but these will get you going with subgroups and enable a whole lot of things that you can do. Key among this is the basic and vote. The basic is what you get with Vulkan 1.1, which basically just tells you how big it is and allows you to elect a single invocation to do something. With a vote and ballot, you can reduce the divergence and control the divergence of how the different invocations or threads are being handled within the system. The arithmetic operations allow you to do things like prefix sum within a subgroup, along with a bunch of other arithmetic operations. And you also have shuffle and shuffle relative, which just let you directly communicate with other invocations within the subgroup. And the last one that we've required is the quad operations. These are very similar to some of the other ones, particularly shuffle. But what they have as a property is that they match the behavior of derivatives in fragment shaders. So if you're using quad operations in a fragment shader, you know that you'll get the same invocations you would get from fine-grained derivative operations. And that allows you a bit more ability to coordinate things like determining if you are going to do derivatives or not based on whether any of the derivative invocations in the quad will do derivatives. A new-ish extension we've added is global priority. This was freshly ratified, but actually is made up of 2 existing EXT extensions. This functionality provides the ability to prioritize queues on different processes. So you may have one queue in one process that needs really tight access to the GPU, and you might tag that as a high priority or even real-time priority queue, whereas your other applications might just be like, yeah, just whenever GPU resource is available. Higher priority queues will get preferentially scheduled onto the GPU for execution. This is particularly important for things like composition, where you have either a VBlank to hit or you have low latency requirements, such as in an XR use case, where you need, as soon as the image is ready, you need to get that thing on the screen as soon as possible. And that's one of the main use cases for the high priority queues, but there are others. Another feature I'd like to highlight, which Tom did mention, is scalar block layout. This one's not too flashy, but it's worth mentioning. This enables applications to define the same structures on the host and the GPU and have them match and not worry about it. If you naturally define, say, a structure in C, and you naturally define the same structure in GLSL or HLSL, using this layout ability, they will match. There will be no need for adding padding or managing byte offsets or anything like that. It doesn't allow you to do things like have unaligned floating point values, like aligned to byte boundaries, but it does allow you to have like a vector of floating point values to be aligned to floating point boundaries. So this basically just simplifies how you can get data between the two processes. There's a whole bunch of other features, notably 8K images are supported, fragment shader stores and atomics, YCBCR image sampling and isotropic filtering, and a whole bunch of others. Again, you can pause to look at this later if you're watching it back, or they are in the spec. A lot of this is driven by, these are features that were optional in 1.0 or future versions that were added because we needed to support the 3.1 baseline for OpenGIS. But most or a large subset of applications just assume they're there or want to be able to assume they're there. So by requiring these, we're now saying, yeah, if you're targeting the roadmap 2022 baseline, you don't have to worry about it. So that's our aim for the roadmap 2022 baseline. We want you to be able to rely on this. We want you to be able to say, I'm going to write an application that is going to be targeting immersive graphics. It's going to release in 2 years. What features can I rely upon? And we want you to be able to start saying, this is the set. There's still going to be discussions about stuff beyond this set of features, and maybe we'll introduce more profiles as time goes on, but this is a baseline we want to be able to have people use. We're very excited to see what people's experience of this is, how people feel about it, what they think is interesting about it, and how it may get used. And I believe there will be a link shared at some point, links to social media and to Discord channel to be able to have that discussion. And with that, I will hand over to Trevor Black from Google, who is going to talk to you about the Android baseline profile. Thank you.
Thank you, Tobias. Hopefully everyone can hear me. Good afternoon, good morning, good evening. I'm Trevor Black. I am an engineer on the Android GPU team at Google. I'm going to be talking about the Android baseline 2021 profile with a strong emphasis on how we attempt to simplify Vulkan development on Android. Let's jump into it. Okay, so because I don't want to spend too much time, this is the bottom line up front. We've already written a blog post. Hopefully some of you have been able to read this already. I'm going to be covering some ground that I go through there. Simultaneously, the Android baseline 2021 profile is a public, human readable, friendly to understand JSON format. It's already available. If you have any more questions that are not answered by this, I encourage you to just go through and poke through it. And then lastly, we will be publishing support numbers, the percentage of the devices in the wild that support the Android baseline profile to the existing Android dashboard. And then on to the presentation. So we started at this from the position of what is the application developer pain point. So as has been said a couple of times in this presentation, there are 180 or more extensions that are sort of optional, and then there is another 100 that have basically been contained roughly within the primary and minor versions. So if an application wants to build a Vulkan backend, they have to query multiple kinds of capabilities. So there's extensions, you'll have features, they're going to be querying what kind of formats are supported, what kind of limits. And due to the fact that there is a tremendous capability of compute capabilities across mobile, this pain point is felt acutely by mobile. There is a very large spectrum of compute and form factors available. All of this is somewhat simplified by the idea of the Vulkan version numbers. Anything core to a version will not need to be individually queried. So you only need to query a version number as opposed to all of the above nonsense. And with the release of Vulkan 1.3, I hope that everyone can agree that this is the simplest this has been since 1.0. But we still felt that there was a lot more work to be done specifically for Android. So that's why we created the Android baseline profile. And the goal, put simply, make it easy for developers to create an application that supports the vast majority of currently active Android devices. So this is multiple Android releases, stemming back to the original Vulkan 1.0 release. We have a range of older devices and newer devices. We have lower end phones all the way up to much higher end devices. The way we went about creating the Android baseline profile was we looked out and said, what were the existing functionality that was available in the market, figured out what subset of that functionality we wanted to push forward into the future. We created as much of it as we did. And then we went off and we refined that with Kronos partners to make sure moving forward, what can we absolutely guarantee on the max percentage of devices going into the foreseeable future. Simultaneously, one thing that we care deeply about is we want this to be able to reach out to Vulkan developers without needing to have anyone update their devices. So again, here is the link for the actual JSON as it exists today. Jumping forward. So because all of this functionality is not brand new, I'm not going to be delving too deeply into what each of these means. They've all been well documented at this point. And if anyone has any questions, I can pause here and people can go on after the fact and look all this up. So right now, the Android baseline profile 2021, if your device supports a minimum Vulkan version number of 1.0.68, that is adequate. And as Tom mentioned in his talk, the big difference for right now between mobile and desktop is compressed textures. So for a application developer producing a Vulkan application for the Android ecosystem, moving forward, a safe assumption is that everything is going to support ASTC and ETC. Simultaneously, that same developer will be able to assume variable color spaces with swap chain color space. They're going to be able to do sample shading and multi-sample interpolation through sample rate shading, updating swap chains in parts, parts of the frame buffer, incremental preset, shader pointers into uniforms, storage buffers, that kind of thing with variable pointers. All these are things that have been fairly well contained within the Android system thus far, and we want to make sure that developers can rely on them. On top of that, the Android baseline profile has broad support and sensible support for dozens of limits. So as a good example, for frame buffer, 4K is assumed. There is limits required in terms of the max image dimension that's required by a device, number of bound descriptor sets, compute work group. On top of that, there is demand support for dozens of formats. Hopefully all of this is fairly self-explanatory as I move on to what it means actually today. So as spoken in previous presentations, Vulkan Profiles is primarily an SDK side change. If a device currently has the required Vulkan support, 1.0.68, and all of the formats, limits, extensions, and features just mentioned, this device will already support the Android baseline profile, and no over-the-air update will be necessary. So as soon as the SDK is out, developers can start poking and prodding around in devices and seeing what the support is. With that said, though, we hope that will matter because we expect the vast majority of Android devices currently in use to just support it. We are going to be doing some work on our end to determine the exact percentage. And just like with the Vulkan numbers, we will be broadcasting the percentage of Android support at the dashboard, developer.android.com, about dashboards. We are planning on having this live around the time of the SDK release. And let's talk about the future. So in that blog post and right now, we are committing to a 2022 refresh of the profile later this year. It's very important to us that we continue to work with our Kronos partners. If you're an Android developer and you have an opinion, you want specific extensions or features, there are formats you don't think are getting enough love, we'd like to hear your opinion. We will be reaching out shortly for feedback from Android developers, and we'd very much like to know what exactly you want to be the future of the Android baseline profile. Simultaneously, we are thinking about how do we want to differentiate between different form factors. So again, Android spans a wide range of form factors. We have phones and wearables, we have televisions and automotive devices. And while the form factors are very different, which implies that you would want a different kind of profile, the hardware tends to be relatively similar. This is a discussion that we're having ongoing. And now, lastly, at the moment, we have no concrete plans beyond a 2022 refresh. We're thinking we'll probably end up updating this about every other year or so, but ultimately this is something we think the ecosystem is best determined as a whole. So we'll update when we have demand from independent software vendors and independent hardware vendors. And that is all I have to say about the Android baseline profile.
Thank you, Trevor, for the overview of the Android baseline profile, and kudos to Google for having this ready for the Vulkan 1.3 release. Next up is our Ask the Experts panel, moderated by Piers, Daniell of NVIDIA. This is your chance to ask any questions about Vulkan and the Vulkan ecosystem. So please submit your questions using the Q&A button at the bottom of your Zoom window. Piers?
Hey everyone, this is Piers Daniell. I work for NVIDIA, and I'm also a member of the Vulkan working group. I'll be hosting the panel today. The specialists on the panel are Tom Olson from ARM, you'll know Tom, Rolf Potter from Samsung, Tobias Hector from AMD, Dan Ginsberg from Valve, Karen Ghavam from LunarG, Christoph Riccio from LunarG, Trevor Black from Google, Ian Elliott from Google, and Frank Yang from Google. It's good to have lots of Google guys here, because I noticed in the Q&A there's actually lots of Google related questions. So keep the questions coming, and I will try and keep up with them and pick out some good questions to share with the panelists. So I'm going to just work down from the top. I see a good question right away that actually Christoph might be a good person to answer. So the question is from Simran Spiller. Speaking of hardware baseline, is there a public online resource of GPU capabilities, as in what is actually supported in hardware? GPU info is great, but it lists the capabilities in terms of API. It'd be interesting to know what could be implemented at the software level for a given device.
Yes, I will answer, but I would say no. There is, because the specification doesn't make a difference between what's a hardware feature or a software feature. So currently we can't really report which one is what. But maybe, and that wasn't mentioned before, we are working with Sasha Willem so that he will be able to export the capability of a report in GPU info in a form of a profile file. So all this report could be used within the toolset we are delivering with the Vulkan SDK.
Yeah, I should also add from my point of view is that it would be a complete waste of silicon if we didn't expose hardware features. If a hardware feature is not exposed through some multi-vendor API, it will definitely be exposed through a vendor API until everybody else adopts it. So I wouldn't say that there's a lot of hardware features that aren't exposed. It'd be a waste.
I think I'd come at it another way as well and say that analyzing whether your GPU can actually support a feature in the specification is sometimes a pretty complicated kind of process requiring a good deal of expertise. It's difficult to see how a public online resource like that would function.
Yeah. Any other panelists want to add to this one before we go to the next question?
Well, we should say that when we specify a feature which already exists in DX, we do pay quite a bit of attention to trying to specify it in a compatible way so that we don't artificially, so we don't end up with something that looks like it could be supported but isn't. Part of that is because we want to be able to support tools like DXVK and D3D12. So compatibility matters to us, and being able to support the features of DX matters to us.
Sounds good. Great question. Thanks for that. So let's move on to the next one. This is from Shay Bolt. Is Google planning on doing anything to get Android vendors to actually support this new baseline? Trevor, you might want to pick this one up.
Sure. Yeah. Repeating the question. What is Android doing to make sure that hardware is actually supporting the Android baseline profile? We're asking them. Overwhelmingly, over the last 2 months, I've spent most of my time going through and communicating with platform vendors to make sure that they support what's in the profile. So fundamentally, this is going to be an ongoing conversation. So yeah, no, we are making sure that everyone that we're talking to supports the profile, and we're going to continue doing that into the future.
Okay. There's another aspect to this question. I didn't quite grok it, but
Maybe I can add something. Because it wasn't mentioned before, but one of the difference with the profile concept with whatever we did in the past with Vulkan API is that it's not a Vulkan API, it's a toolset. So what's going to happen is that this toolset will work on Android devices. So there is no need to update the driver to have the Android 2021 working or for any devices. So as soon as we release the SDK, you will be able to use the profile on the devices, which is really a strong point with the profile design, in my opinion.
Yeah, that's a good point. That was absolutely design criterion number one for us for the profile system was this has to apply retroactively. It has to exist outside the API so that we can do things, we can write new profiles that describe old devices.
Yeah, and that also applies to the roadmap 2022. There's already a lot of devices that can claim support for that, which is really great.
Right,
So
I forgot, I have to ask you, Piers, because you would know, and Tobias, and we don't have anybody from Intel. I assume your 1.3 devices already support roadmap 2022, is that correct?
Yes, that is correct.
Yeah.
Now that KHR global priority has been released, that completes the picture. Yeah, and our drivers do support that.
Great.
I think one important detail about the Android baseline profile is one way that it differs from the roadmap is the baseline profile is documenting devices that already exist. So it's been done in collaboration with GPU vendors, but it's also a survey of what already exists. And so this question of what do Google need to do to force people to support it is a little bit moot because it's more like a survey of historical releases than a set of requirements.
Yes.
And we're unlikely to drop features from GPUs.
Yes. This question was asked before my presentation. Hopefully the response that an over-the-air update will not be necessary is ultimately what the asker would like to hear.
All right, good question. All right, let's move on. This one's from Mike Bailey. Oh, hi, Mike Bailey. I know you. Is there somewhere I can find information, a la a man page, on just an individual extension? Do I have to get the full information? Did it get that information from the full spec? I think this is a quick one. Usually, if you just Google the extension, the page you hit is something that is the extension overview, and it gives you links to all the parts of that extension. I don't know if anybody wants to add to that.
Yeah, there's two other things that are probably worth being aware of. One of them is the Vulkan guide, although if you Google that, you may end up with the other guide. It's slightly confusing. We'll try and make sure there's a link available. Someone please. But the Vulkan guide tends to cover extensions from a more developer-focused point of view. So if you can't find what you're looking for in the extension appendix man page, the information might be there. Something we're also, thank you, Chris, it's in the chat if you haven't seen it. Something else that we've been trying to do more recently is we've been producing proposal documents for our extensions so that they cover everything from the start of the design all the way through to the philosophy of why and actually the details of all the bits of the API that you need to worry about. This serves three purposes. One, gives us a good design. Two, gives the implementers a good idea of what the heck they're actually trying to aim for. And three, finally serves as a good documentation for developers and anyone else who wants to look at it. These are always linked from the extension appendix man page if you want to have a look at it. So if you just scroll down a little bit, you should see design or proposal document, I forget which, and just click that and you'll get a full, very detailed overview of the extension.
Great. Yeah, good question. Thank you. All right, the next one from Adam Suvaks. Sorry if I said your name wrong. Would it be valuable to have a good shader testing tool with good debugging capabilities, a bit more shader focused than RenderDoc?
So I have a couple of comments on this. It's not a direct answer to the question, but maybe some useful information. So one of the new extensions, or well, one of the extensions that's part of 1.3 is the KHR non-semantic info SpearV extension. And there's been some work ongoing to to put full debugging information inside of SpearV. So Greg Fisher at LunarG and Balder on RenderDoc have patched DXC so that it'll now generate full debug info, and they're working now on doing the same thing in GLSlang. And I'm not sure exactly what state it's in RenderDoc today, but there is work going on to do a full shader debugger. So all those things are happening. That doesn't really answer the question about does there need to be a better testing tool about shader debugging, but I think if there was, it could leverage some of that new work that's going on.
Yeah, and of course, for those who really need to debug their shaders now, you always have printf.
Elf uses the non-semantic extension, so there you go. Yeah, I think this is the sort of thing where, as we start looking at our roadmap, as we've sort of committed to saying more about it as we go through the year, it's not just API features. I don't know if we've communicated that clearly enough, really, but it can include things like, hey, we need better ways to debug shaders. That could be a goal for us in the roadmap. That might end up being some API features, but it might also be tooling. So this is, this is the sort of thing that we're going to be trying to discuss moving forward to see if there's some value add we can do to make developers' lives easier.
Yeah, I'll call back to my presentation as well. We consider that your problem is our problem. So if debugging is #1 for you, it's #1 for us too. Of course, we're averaging across the community, but.
All right, good question. All right, so let's move on. This is from Paulo Pinto. Regarding Android, will it ever provide a Vulkan kit similar to Metal Kit instead of the bare bones reference to a GitHub repo? Perhaps one of the Google guys would like to jump on this one.
I am going to throw this over to Frank, actually.
Thanks for the question. So when you're developing Vulkan apps or Android, we do provide links to resources such as the NDK and Android Studio. However, we do understand that there may be some pain points in how this integrates with the rest of the Vulkan SDK and tools. And you're right that there could be a use for a Vulkan kit similar to Metal Kit to make Vulkan development easier on Android. So it's definitely something that we will look into. One of the things that we are working on is Android GPU Inspector, which allows you to profile in great detail the performance aspects of your Android Vulkan application. And we're also working to provide better support for RenderDoc as well for frame debugging. But you're totally right that this is an area where Android can make it easier for developers to program on Vulkan apps on Android.
All right, good. Anything to add from anybody else? All right, let's jump to the next question. This is from Christian Rossell. Sorry if I said that wrong. For certain scenarios, it'd be extremely helpful to extend draw index indirect command to include a index type to switch between index type 16 and index type uint32 within the command draw index indirect call. Also, it'll simplify code a lot if we would include a vertex offset array to be able to use different offsets for vertex buffers. I think that this is basically a general question is about draw indirect and can we make it better? This might be Tobias might be a good person to start on this one.
Yeah, like so this is by far not the only request we've had for draw indirect type stuff. There's at least one Vulkan docs repo, and I'm sure I've heard several others from various sources over the years. GPU driven rendering, which is this is a subset of in terms of being able to make better and different decisions on your GPU about what is going to happen in your scene when you're actually running your frame loop, is an area of active interest. It's something that I know there's. It's one of the things I think in 2019 we had these objectives we thought we would try and do, and one of the things that got discussed then as an option for one of our objectives was GPU driven rendering. It was ultimately prioritized out, but it's going to come up again. As we start talking about future roadmap, it's probably going to be one of the big ticket items that we think about. Whether it gets prioritized or not, I can't say for sure right now, but certainly it is of interest, certainly to a large number of member companies, AMD included, certainly NVIDIA as well, to have this sort of capability available to GPUs. I don't know that it'll look exactly like you've proposed, but making that kind of decision on the fly is something we want to look into. If you have specific features that you want to see, it's useful if you can go and post on the Vulkan docs repo. So we've got the issue to track it, because when we do start tackling all of this, we'll want to go and collate all that feedback and make sure we're covering it if it's appropriate and viable.
That's a very good point. You may have figured out from my presentation that it's typical for us after a release, which we've just had, to be in requirements gathering mode for the next go round. And so we will be brainstorming device capabilities and developer priorities, and the more information we have, the better off we are. So yeah, raise issues on the spec repo. We'll tag them as future or feature request, but we absolutely will pay attention.
NVIDIA has a vendor extension that you can play with as well, the NV device generated commands extension. It's quite feature rich for the GPU generating commands for itself to execute. And then I think DX12 has something a little bit beyond what Vulkan can do today. So that would definitely be a minimum bar that we might shoot for. Anybody else want to add to indirect rendering or device generated commands?
If I can allow myself, I'm wondering, but maybe I'm opening a debate that
Debate is good.
open now. So historically, I really enjoy and thought there were a future for GPU-based rendering, GPU-driven rendering based on multi-draw indirect and that sort of thought. But it seems now that we are seeing more and more games, I would say, but even micro benchmark showing that you can be quicker with compute-based solution. So is it really making this small and specific? So each time we had a new multi-draw indirect feature, it was always a very potentially fixed function hardware accelerated improvement, potentially, I would say. But is it really the future of graphics with Vulkan? And maybe people won't have
this is going to be fun.
Yeah, this is a controversial question.
Can I say mesh shaders? Let's say mesh shaders. No, sorry, go ahead.
Look at the next question. Like, Piers, maybe because we're basically spilling into that one.
Yeah. Okay, so the next question reads, along the lines of improving GPU-driven workloads, will we get GPU device function pointers? Actually, this is a really great question. And being able to execute shaders from other shaders. Okay, so two parts there, like in the ray tracing extension. So yeah, I feel like there's two features you could peel out of that. For the device function pointers, there are definitely places in the API where you can't pass around the physical buffer device addresses yet, and that's something on our radar. And then executing shaders from other shaders is something we thought about. Tobias, do you have something you want to say to this one?
Sure. Yeah, I can talk a bit about it. Yeah, so it's kind of tricky. So for the ray tracing, we've added, the ability to do shaders from shaders in the way that it's done because we were trying to have compatibility with other APIs. Whether that's the exact formulation of what we want for the rest of the API is up in the air. It's something we have yet to discuss properly, at least within Kronos. But it is something that we want to look at because the way in which you interact with the GPU and CPU is quite different at the moment. There's this assumption of inlining, which you can't do if you're jumping around shader code. There's these assumptions of, it'll just run fast. You can just put it on the stack if you come from CPU land. which doesn't really quite work for a GPU because the amount of stack space you have per thread is generally very low, or otherwise you end up with like an enormous, ridiculous amount of memory backing in VRAM, which kind of starts to go beyond what you actually start seeing on consumer GPUs. That said, it is something we want to look at. Again, it does filter into what Christoph was saying in terms of GPU-driven rendering. We do want to enable more and more interesting ways of moving around between code and from the GPU side. And I think it's something we will be looking into. I don't know what the format of that's going to be yet. I think that's something we're going to have to do a lot of design work if we're going to tackle it. And yeah, watch this space, I guess. Certainly, if it is something we want to try and tackle, we will be telling you that in the form of the roadmap update later this year.
Okay, good. Actually, I wanted to pick Dan on this one as well. Is this something that's cropped up as a developer? Something that's interesting for you?
The specific one of device function pointers and invoking shaders from other shaders, or just generally GPU driven rendering?
Just generally GPU driven rendering, yeah.
Yeah, I guess, yeah, coming back to Christoph's question, I'm not sure I agree with the premise that people are moving away from GPU driven rendering. Seeing a lot of applications that are doing culling on the GPU and compute shaders and issuing indirect draw commands. And definitely these questions here about expanding the capabilities toward what NVIDIA device generated commands can do, or somewhere along those lines, is something we would like to see. Obviously, it depends on the capabilities of the GPU, but at a bare minimum, having DX12 level execute indirect is high on the list of things we care about, especially from the point of view of Proton.
Mm-hmm. All right, thanks. Anybody else want to add to that?
Maybe I misunderstood what Christoph was saying. My understanding was not that it was move away from GPU-driven rendering, more that it was a move away from rasterization as the end goal. At least that's how, that is a point I agreed with. So I just wanted to like clarify, see what the point was. I'm not sure. Christoph's laughing, so maybe I'll let him speak for himself, but I would like
very
to.
open-ended.
Right. Because I do think we are seeing, for particularly high-end graphics, a move away from putting stuff into the rasterization pipeline and moving in towards people putting stuff in compute passes, which is a trend that you're certainly seeing in things like Nanite with UE5 or with other modern rendering techniques that you'll see at GDC. People are using more and more compute shaders as opposed to rasterization, or still using rasterization for the bits it's actually good at, as ways of accelerating fixed function parts where appropriate, rather than trying to stuff everything down that pipeline and work around the edges.
I think my maybe non-controversial answer to Christoph's original question is there's a really big design space here, and I'm not sure that I'm not sure as an industry we have a nailed down agreement on what works, what makes sense, where we're going. So would I expect to see more things in this space? Yeah, absolutely. Do I know what they look like? Do I know if they're compute or if they're modifications to draw indirect? I think there's long technical discussions to be had and arguments to be made on that one yet.
In other words, welcome to the bleeding edge.
Yeah.
Yeah, and
which I'm afraid is a non-answer, but
yeah, well, this is the kind of stuff is what makes Vulkan great. It's an innovation platform for all its members. As a committee, we get to innovate together, and it's an open platform, and that's where we can show the world what's next. So there's definitely a lot of things going on in this area, and Vulkan's the place to be. All right, let's move on. This next question is from Simran Spiller. What are the chances of getting Vulkan video support on desktop GPUs from the past few years? According to GPU, there's only a handful of top-of-the-line NVIDIA cards that support Vulkan video so far. Let's see. So I can say that the Vulkan video extension has been released. It's in its provisional form. It's not final yet. I think it's going to be final sometime later this year. It could be the case that folks are still developing their drivers, and since it's not quite final yet, they don't want to like put something that's changing. I don't know, but there are all the desktop GPU vendors are working on it, so I expect that when it's final, everybody will have an implementation. The great thing, of course, about Vulkan Video is that I think it's the only video acceleration API that's cross-platform, multi-OS, multi-vendor. So I think once it's out, it's gonna be really great. Does anybody want to add to Vulkan Video? All right, next. Hi, this is from Luke. Hi, are there any plans to support ray tracing in the core Vulkan API? Tom, you would be a good one to tackle this one.
We just sort of said that we've settled on a path for the next little while of not putting optional functionality into core versions. And the reason we're doing it is to keep the core accessible to devices of quite low spec, lower than, in fact, your average mid-range cell phone. At this and then use profiles in order to define feature sets, more feature-rich feature sets. So I guess the short answer is it's not likely to happen. It's not to say that we aren't fully committed to the ray tracing path, and you certainly will see devices in the what Tobias named the immersive graphics set, which includes cell phones, which do support some level of ray tracing, but core spec probably not.
This is the kind of thing that's perfect for profiles.
Yeah.
So, one day you can imagine profiles that represent a very specific segment of the industry that helps users and developers, and yeah.
I should say, when we started talking about profiles, you can slice up device space in many ways. And one way we considered slicing it up was more by functionality. So we talked about the possibility of a ray tracing profile. This is the functionality you need. This is what we expect a basic ray tracing capable device to do. We decided it wasn't wise, and you'll notice we were very conservative. There's only one Vulkan roadmap. We don't have one for desktop, one for mobile. We don't have one which is ray tracing specific. Because we said we're starting from everything, a sea of capabilities. Going immediately to very narrow slices is, well, it would replace extension or capspit hell with profile hell. We didn't want that. So, well, sorry, bit of a digression, but.
Okay, anybody else want to add to that? Ray tracing on mobile, I'd love to see that.
Oh, there are demos now.
Nice.
I believe we've announced GPUs with ray tracing on.
Very cool. So I guess you're probably looking forward to a ray tracing profile.
I think I'm in the let's not slice things too finely camp.
Yeah, this is something of a controversial topic, and I feel like there's going to be a lot of people reticent to say very much right now.
Yeah.
But ray tracing is kind of hard to ignore, and it's certainly something we'll be talking about and continuing to talk about in the working group.
Mm-hmm. All right, let's move on then. Another question from Shay Bolt. On the roadmap, will we see buffer device address, but for workgroup shared memory? Will we see an extension with this in the desktop profile, given all desktop GPUs support this?
I assume this is thinking about OpenCL, which has this capability. I mean, it's not something I think we've actively discussed, although we have had this nagging idea of doing like GPU, compatibility on some level with OpenCL over time, because we do value Vulkan as a compute platform and think it's quite useful for that. Certainly adoption-wise, it has way more adoption than OpenCL. Pointers to working group stuff, I don't know, maybe. It's, again, a thing I would say, go raise an issue on the GitHub. and we'll look at it because every time something's there, it puts it on our radar to some degree, so we know to think about it and look at it. I don't think we have any current plans for that, but we can look maybe.
Yeah, definitely. If there are ideas, please file them as GitHub issues. All right, there was a question on here that Christoph wanted to answer. It kind of disappeared from my list, but I'll try and find it. So the question was, can you talk a little bit about how, as a developer, we can use the SDK with profiles? Is there any feature to help us create instances devices with all the features, extensions for a profile enabled? Christoph?
So as Karen mentioned, there is a 3 component, one of which is an API library. The API library is generated for each revision of the Vulkan API. And what it can do, it can query in the C++ application in the game. Is the platform supporting a specific profile? Or but also creating a VK device using a selected profile. And there is also a lot of API to do reflection on the profile so that you can list what's supported by the API in your application. And I guess that's the answer.
Okay. All right. Anybody wanted to add to that? All right.
So maybe something I didn't say. It's the library will be in the SDK next to Vulkan.h, so you can just include it. It was really designed to be easy. You don't need to have a JSON file. You just include a header, and you can use it in your application. So it's it should be very straightforward and very simple to integrate.
Mm-hmm. All right, thanks, Christoph. All right, so we're getting to the bottom here. Let me just see if I can pick out a couple more interesting ones. I'm not sure who can talk to this one. So the question is, this is from Celestin de Villa. Is there any news on a new extension intended to replace the defective KHR swap chain? Ralph, you might be a good person to pick this one up.
I'm not sure how good so there is work going on. I don't think we're ready to announce anything right now.
But the problem is recognized, right?
The problem is definitely recognized. The problem has had months and months of discussion. It's pretty complicated.
Mm-hmm.
It might be worth pointing people at the fact that on Linux, at least, there are extensions that allow you to completely bypass the swap chain already via external image sharing. It's something that is notable as, hey, we don't actually have to manage all the swap chain stuff in the Vulkan API. And it's a model we're paying attention to. I don't know how much adoption that has in the developer community, but I do know at least that there was an effort underway. I think it might be used in Mesa right now, where the swap chain stuff was rewritten as a layer on top of image sharing to sort of stabilize and standardize things. It's an interesting direction, at least.
Mm-hmm.
I think one point to make here is swap chain specification is pretty complicated when you only control one half of the chain, and the other half, the presentation engine, is not entirely under your control. So yes, there's work. It's long running work. I don't know that we have anything to announce right now.
Mm-hmm. Okay. Next question from Rafael Kowalsiak. Sorry if I got that wrong. Development plans for unlinked non-uniform GPUs rendering. I think this is asking about heterogeneous rendering, GPUs from different families or vendors working together. But yeah, I don't think there's any specific plans for that. But if you have some specific ideas, GitHub, file an issue on GitHub. Are there any plans to have something to control memory residency similar to D3D evict?
One of our favorite questions.
I can take that one if you want.
Yes, please. Yeah.
I might need some help, but so there is an extension. It's not part of 1.3, but it's VK-EXT pageable local device memory.
Mhm.
And this helps quite a bit with this problem. Prior to this, the behavior of what happens when you oversubscribe GPU memory was kind of different across different devices and operating systems. If it was on AMD, for example, there was an extension you could use that was AMD specific to control oversubscription behavior. On NVIDIA, you would get a device out of memory errors. So at least with this, you do have the ability to, on Windows, have some control and dynamic behavior with controlling residency. It's not as explicit as the D3D evict, but it provides some similar controls. We have talked about going as far as some of the very Windows specific APIs in Kronos, but this is a step towards it. But if there's more functionality that you feel like you need, yeah, please file an issue in Vulkan docs, because we've heard this from a lot of developers that it's a serious issue, and we've experienced it too on our side.
Yeah, definitely check out EXT pageable local device memory. It's meant to solve a lot of these problems. Anybody want to add? Anybody else want to add to that? All right. So I'm probably going to wrap this up soon. So I'm just going to pick up a couple of last questions. This is a good one for the Android team. Will Vulkan profiles in the form of JSON be integrated into the Play Store as a feature-based filter?
I can answer that one very quickly. It's my interpretation of this question is that will a user be able to click a button and say, I would like to only see the applications that are using the Android baseline profile. Hopefully that's what the asker means. And so right now there is no plans to do that. Primarily for Android baseline profile, the idea is to make it easier for developers to understand if they're shipping a game on Android or an application on Android that uses Vulkan, what is the functionality that they can rely on. In terms of a user-facing functionality for that, it's not necessarily clear on our side how a user would necessarily benefit from knowing that this application is guaranteed to have a 4K buffer. That's something we'll discuss internally, but right now it's more of a utility for developers. How that's useful to users will be an ongoing discussion.
Okay.
Yeah, we'd appreciate more feedback on how we on possible use cases for developers and end users of having more profiles on top of APP to control Play Store filtering, especially for the higher end mobile games.
All right, thanks. All right, I'll pick up a couple more. So this one is from Manas Kulkarni. Is there any plan to create a way for getting more accurate GPU timings on mobile through Vulkan timestamp queries? Currently, they're pretty much useless in some render path scenarios. And I think this lends itself to the bigger question of debugging on mobile and hardware in general. Ralph, is this something that you want to pick up?
Yeah. So I guess there's two aspects to Piers' question. If I jump straight to timestamps, because of how tile-based deferred renderers work, timestamps inside a render pass are fundamentally kind of hard to get useful information out of. Your GPU can be doing lots of deferring when your pixel shaders running them in orders that you didn't expect them to. Do you want the timing for the first tile that was processed or the last? So if you have specific asks where you think the timestamps could be better, then Vulkan docs issues telling us what's missing would be good. But it's really hard to give you precise timing on a tile-based GPU just because of architecturally how they work. More generally on debugging or GPU debugging in general, we do have some work going on kind of crash debugging, diagnostics, that sort of thing, which we're not ready to share particular extensions right now, but we've had ongoing work for the past year on kind of improving the developer experience and understanding what's going wrong on your GPU. So that's something to look for in the future.
I'll also throw in a plug for the Android Graphics Inspector, AGI, which Google released and has newer versions coming out on a somewhat regular basis. And there's a lot of effort to make it a much better profiler. Maybe won't solve the Tyler problem that Ralph mentioned, because that's just a difficult hardware problem, but it can definitely give insights into performance. There's both the system trace aspect and a drill into a frame aspect. And so I encourage you to try it out. And again, there will be a newer version coming out, which will make it even better here in the near future.
Yeah, I'll second that plug. The new AGI stuff is really good for this kind of timing information.
Great. All right, good. I'm glad we could segue that extra information there. All right, one last question I'm going to pick up from the Q&A. This is from Duncan Hopkins. Any plans for Vulkan version of direct storage, ability to DMA from storage to GPU visible memory? Anybody dare to pick this one up?
Kind of assumed you would try and do that one, but you don't have to. I mean,
yes, go on, Tobias.
All right, fine. I'll do something. I think we've answered this on a GitHub repo anyway, on the GitHub repo anyway, which is that it's an interesting feature. We haven't got any plans to announce right now. We'll look at it. I don't think we can say any more than that at the moment. It is a bit tricky because it's kind of tied to file system rather than directly to the GPU, although obviously there's some interlink there. But yeah, we're thinking about it, but nothing firm at the moment.
Yes, definitely not the first time we've heard this one, so we are thinking about it for sure. All right. I think that's all that we're going to pick up. Any final words from the panel? Any panelists before we end the session?
Well, I'll reinforce what Piers said. Raise issues. This is the time when we are in requirements gathering mode for the next go round, and we would love to hear what you need.
Sounds good. All right. Well, this ends the Q&A portion of this webinar.
Yes. Do you want to? There's literally one question left on the Q&A. Should we talk about that one quickly?
Yeah, maybe. Is it the one literally on the last list? Are there any plans to improve the Vulkan shader development comfort, for instance, by improving the base GLSL language, adding shader debugging support, or improving IDE support? All right, Tobias, you have to answer that now.
But I didn't want to leave one person dangling there without their question being answered. It's mean. Oh, go ahead, Dan. Dan, you go ahead.
I'm just reiterating on the second part of it, the shader debugging support. Yeah, there is a lot going on for that. Like I mentioned, DXC has patches now to generate debug info, and GL Slang will as well. But that doesn't answer the first and third part of that question.
Well, one thing we should say is that we're very aware in Kronos that GLSL, in terms of maintenance outside of Vulkan, has become a bit of an orphan. There's a lot of interesting, the spec is open source. There's a lot of interest and a lot of smart language people suggesting things that could be done to make GLSL more modern and keep it developing and moving forward. And we don't want to just let that stuff rot. It's really an organizational problem and a priority problem. So knowing that you care, you're not the only person who has asked this question. Knowing that you care helps. We are kicking it around, and it is probably one of the things we'll do, as I said, as we move into the cycle for the next, I don't want to say 1.4, but the next Vulkan. We'll be looking at how to organize to do the things we want to do. And if making GLSL more of a, to bring it into the modern world is a priority, that's something we can organize for.
And something we definitely do is to try and make SPIR-V better to accommodate other high-level languages. So if there are requests that come in that if you just add this to SPIR-V, then now we can support C++. Yeah, we definitely are open to supporting that.
And I think it's also worth, sorry, Piers, to mention that all new Vulkan functionality that does have language requirements is being implemented in GLSL, in GL Slang, and there's no plans to stop that. So it
Absolutely.
will fundamentally keep expanding for new Vulkan functionality to the extent it needs to.
Right. Sorry. The only sense in which GLSL is an orphan is that we have not added new features that weren't directly driven. So, templates. Should we have templates in GLSL? We haven't talked about that. But in terms of maintenance, in terms of keeping the engine going, almost the whole conformance test is written using GLSL to generate the shader code. So the tool is absolutely live and fully supported. It's only the kind of language design syntax, the very highest level, that is kind of not progressing as fast as it could.
Okay. All right, I didn't see any new questions come in after that, so I think this will be a good time to stop. The conversation will be continued on Discord if you have any follow-up questions, and I think the Q&A will be published after the event. All right, well, thanks everyone for attending the Q&A session. I'm going to hand it back over to Jeff to close out.
Thank you, Piers, and thank you to all our presenters and panelists today. We greatly appreciate your time and efforts in getting this latest Vulkan specification launched. And thank you, attendees, for your time. We hope you enjoyed the webinar. As a reminder, a recording of this presentation along with the slides will be available on the Kronos Group website, and a direct link will be sent to you in a follow-up email. Also, there are multiple ways to get involved. For instance, you can join us on Discord, as previously mentioned, and continue the discussion and share feedback with us. As you leave this webinar, please take a moment to fill out the survey that pops up. Your feedback is very important to us as it helps us improve these presentations. Please let us know if there are other Kronos related topics you may be interested in. Thank you for joining us and have a great day.